Hi dear friends, we are going to say about the embedded programming in embedded and real-time systems. First, we want to know about the types of components for the embedded programs. There are three main components are there in embedded programs. First one is a state machine, second one is a circular buffer, and the last one is a queue. State machines are well suited to reactive systems such as user interfaces. The circular buffer and queues are useful in a digital signal processing. In a state machine, the input appears intermittently rather than as periodic samples. It is often convenient to think of the system as reacting to those inputs. The reaction of the most systems can be characterized in terms of the input received and the current state of the system. In a circular buffer, it is a type of data structure that lets us handle the streaming of data in an efficient way. To avoid the constantly copying the data within the buffer, we will move the head of the buffer in that time. The buffer points to the location at which the next sample will be placed. Every time we add a sample, we automatically overwrite the oldest sample, which is the one that needs to be thrown out. When the pointer gets to the end of the buffer, it wraps around to the top. The last one is a queue. It is also used in a signal processing and event processing. Queues are used whenever the data may arrive and depart at somewhat unpredictable times or when variable amounts of data may arrive. One way to build a queue is with a linked list. This approach allows the queue to grow an arbitrary size, but in many applications we are unwilling to pay the price of dynamically allocating the memory. This is the block diagram of the compilation through the loading. First, the high-level language code will be applied to the compiler. The compiler create one assembly code, then it will be applied to the assembler. It will create one object code, then it will be linked by linker and create one binary code. It will be finally loaded and executed for the system. There are three main compilation process are there in embedded program, that is assembly, linking and loading. The assembly and linking are the last step in the compilation process. They are turn a list of instructions into an image of the program bits in a memory. Loading actually puts the program in memory so that it can be executed. Generating assembly language rather than a binary instructions frees the compiler writer from details extraneous to the compilation process. The assembler job is to translate symbolic assembly language statements into bit level representation of instructions known as an object code. Assembler takes care of instruction formats and does part of the job of translating labels into an address. That file may not necessarily be located in the CPU memory, however, unless the linker happens to create the executable. Directly in RAM, program that brings the program into the memory for execution is called the loader. Most assemblers therefore allows us to use relative addresses by specifying at the start of the file that the origin of the assembly language model is to be computed later. When translating assembly code into object code, the assembler must translate opcodes and format the bits in each instruction and translate labels into the address. Labels that the programmer avoid worrying about the location of an instruction of data. Label processing requires making two passes through the assembly. The first pass scans the code to determine the address of each label. The second pass assembles the instructions using the label values computed in the first pass. Next, the symbol table is built by scanning from the first instruction to the last. Despite the similarly name to a program counter, the PLC is used to execute the program only to assign memory location to the labels. At the end of the first pass, the assembler rewinds to the beginning of the assembly language file to make the second pass. During the second pass, when a label name is found, the label is looked up in the same symbol table and its value substituted into the appropriate place in the instructions. Finally, in a linking, Many assembly language programs are written as several smaller pieces rather than as a single large file. Breaking a large program into a smaller file helps delineate program modularity. The place in the file where a label is defined is known as the entry point. The place in the file where the label is used is called as an external reference. In a linking process, that linker proceeds in two phases. First, it determines the address of the start of each object file. The order in which object files are to be loaded is given by the user, either by specifying parameters when the loader is run or by creating a load map file that gives the order in which files are to be placed in a memory. At the start of the second phase, the loader merges all the symbol tables from the object files into the single large table. If a label cannot be found in a merged symbol table, it is undefined and an error message is sent. After that, the power analysis, that is energy and power optimization, is very important concern in an embedded program creation. Power consumption is a particularly important design metric for battery powered system because the battery has a very limited lifetime. However, power consumption is increasingly important in systems that run off of the power grid. We may be able to replace the algorithm with others that do things in clever ways that consume the less power. We may be able to turn off parts of the system such as subsystems of the CPU, chips in the system and so on when we don't need them in order to save the power. The memory consumption is important concern. We know that memory transfers are by far the most expensive type of operations performed by a CPU. As a result, a biggest payoffs in energy optimization come from properly organizing instructions and data in a memory. Caches are an important factor in energy consumption. On the other hand, a cache kit saves a costly main memory accesses. Analyze cache behavior to find the major cache conflicts. Restructure the code to eliminate as many of these as you can. Moderate loop uncontrolling eliminates some loop control the overhead. However, when the loop is unrolled, too much power increases due to the lower hit rates of the straight line code. Eliminating recursive procedure calls when possible saves power by getting rid of functions called overhead. And finally, testing, that is a program testing, is very important concern in creating the embedded program. In a complex systems need testing to ensure that they work as they are intended, but bugs can be substituted, particularly in embedded system where specialized hardware and real-time responsiveness make programming more challenging. There are two main types of testing strategies are there in various combinations in embedded programming. First one is a clear box and another one is a black box. That is, clear box is also called as a white box. That is, a white box method generate test based on the program structure. The control and data flow graph extracted from a program source code is an important tool in developing the clear box test for the program. To adequately test the program, we must exercise both its control and data operations. In order to execute and evaluate this test, we must be able to control the variables in the program and observe the results of the computations such as manufacturing testing. In general, we may need to modify the program to make it more testable. Accomplish the following three things in a test we must follow. That is, provide the program with inputs that exercise the test we are interested in. Second one, execute the program to perform the test. And the last one, examine the outputs to determine whether the tests were successful. The last one is a black box testing. Black box tests are generated without the knowledge of the code being tested. When used alone, black box tests have a low probability of finding all the bugs in a program. There are two types of black box testing are there. One is a random test and another one is a regression test. In random test, the random values are generated within a given distribution. The expected values are computed independently of the system, and then the test inputs are applied. A large number of tests must be applied for the results to be statistically significant, but the tests are easy to generate. In a regression test, when tests are created during early stages in the system design for previous versions of the system to avoid the bugs in the embedded programs. Thank you.